times in history, NASA's mistakes turned the dream of space exploration into a nightmare. 17 astronauts never came home because of failures that could have been prevented. These weren't accidents. These were warnings ignored, risks accepted, and lives lost because someone made the wrong call. Apollo 1. The fire that should never have happened. January 27, 1967. Cape Kennedy, Florida. 3 astronauts climbed into Apollo 1 for what should have been a routine test. Gus Grissom, Ed White, and Roger Chaffee sealed themselves inside a spacecraft that would become their tomb in less than 15 minutes. The test was called a plugs-out test. The spacecraft sat on the launch pad, fully pressurized, running on internal power. No fuel loaded, no real danger, or so NASA thought. This was just a dress rehearsal for the actual launch scheduled for February 21st. At 6:31 p.m., the 3 astronauts were strapped into their seats. The hatch closed and locked with 3 separate layers. Pure oxygen filled the cabin at 16.7 pounds per square inch, higher than atmospheric pressure. This wasn't unusual. NASA had been using pure oxygen environments in spacecraft since the Mercury program. But pure oxygen is incredibly dangerous. Everything burns faster and hotter in pure oxygen. A tiny spark becomes an inferno in seconds. Materials that barely smolder in normal air explode into flame in pure oxygen. The Soviet space program had already experienced a fatal fire in a pure oxygen chamber in 1961, killing cosmonaut Valentin Bondarenko. NASA knew about this incident but dismissed the risk. The Apollo 1 cabin was a tinderbox waiting for ignition. Velcro-covered surfaces throughout the spacecraft. Nylon netting stretched under the seats to catch dropped tools and equipment. Coolant lines containing flammable glycol ran exposed through the cabin. The Environmental Control Unit used flammable materials in its construction. Over 30 pounds of combustible materials filled a space smaller than a walk-in closet. The wiring was even worse. Miles of electrical wire snaked through the spacecraft, much of it with damaged insulation. During construction and testing, technicians had stepped on wires, pinched them in panels, and scraped them against sharp edges. Any exposed wire could arc and spark. In pure oxygen, that spark meant death. The test dragged on for hours. Communication problems plagued the crew. A high oxygen flow created a loud rushing noise in the cabin. Static filled the radio channels. Grissom grew frustrated with the constant interruptions. At one point he asked, "How are we going to get to the moon if we can't talk between 2 or 3 buildings?" The astronauts had been sealed in the cabin for over 5 hours when disaster struck. At 6:54 p.m., sensors detected a power surge in the spacecraft. 10 seconds later, the crew reported a fire. "Fire!" The voice was likely Roger Chaffee's. "We've got a fire in the cockpit." The flames spread with terrifying speed. In pure oxygen, materials that normally resist fire became fuel. Nylon netting under the seats ignited instantly. Velcro patches burst into flame. The fire raced across every surface, consuming everything in its path. Ed White reached for the hatch mechanism. The inner hatch required a ratchet to open, a process that took at least 90 seconds under perfect conditions. The hatch opened inward, which meant the pressure building inside the cabin pushed it closed even harder. With flames engulfing the cabin and pressure building rapidly, opening the hatch was impossible. The astronauts fought desperately to escape. White struggled with the hatch mechanism even as flames surrounded him. The heat was unbearable. The smoke was toxic. Carbon monoxide, hydrogen cyanide, and other deadly gases filled the cabin. The last transmission came just 17 seconds after the first report of fire. The audio is garbled, but investigators believe it was either "we're burning up" or "I'm burning up." Then silence. The pressure inside the cabin built rapidly as the fire consumed oxygen and heated the air. At 6:31:19 p.m., just 25 seconds after the fire started, the cabin ruptured. The hull split open along a seam. Flames and smoke poured out into the white room surrounding the spacecraft. The pad crew tried desperately to open the hatch. The heat drove them back repeatedly. They grabbed fire extinguishers and fought through the smoke. The hatch was still under pressure, making it nearly impossible to open. It took more than 5 minutes to get all 3 layers open. All 3 astronauts were dead. The fire had lasted less than 30 seconds, but it was enough. The heat inside the cabin had reached over 1,400 degrees Fahrenheit. The astronauts died from cardiac arrest caused by inhaling toxic gases, not from burns. Their spacesuits had melted and fused to the nylon netting beneath them. The investigation revealed a cascade of failures that went far beyond the immediate cause of the fire. NASA had known about the dangers of pure oxygen for years. The Air Force had conducted tests showing how quickly fires spread in pure oxygen environments. NASA had the data. They chose to ignore it because pure oxygen was simpler and lighter than a mixed gas system. The Apollo 1 cabin contained over 30 pounds of flammable materials that should never have been there. Wiring ran exposed throughout the spacecraft, creating countless potential ignition sources. The hatch design made emergency escape nearly impossible. The spacecraft had no fire suppression system. There were no fire extinguishers inside the cabin. Engineers had raised concerns repeatedly. North American Aviation, the contractor building the spacecraft, had documented over 20,000 defects and problems with the Apollo spacecraft. Quality control was a nightmare. Workers were cutting corners to meet deadlines. Inspectors found sloppy workmanship throughout the vehicle. Gus Grissom himself had been so frustrated with the spacecraft's issues that he hung a lemon on it during one inspection, a clear signal that he considered the vehicle substandard. He told his wife that if there was ever a serious accident, she should make sure people knew the truth about the spacecraft's problems. But the pressure to meet President Kennedy's deadline to reach the moon by the end of the decade pushed safety concerns aside. NASA was in a race with the Soviet Union, and schedule mattered more than caution. Every delay meant the Soviets might get to the moon first. The political pressure was enormous. After the fire, NASA was forced to confront the reality of what they had done. The agency had sacrificed safety for speed. They had ignored warnings. They had accepted risks that should never have been acceptable. The fire changed everything. NASA redesigned the Apollo spacecraft from the ground up. The pure oxygen atmosphere was replaced with a nitrogen-oxygen mix at launch, switching to pure oxygen only after reaching orbit. Flammable materials were removed or replaced with fire-resistant alternatives. The hatch was completely redesigned to open outward in seconds. Over 1,300 changes were made to the spacecraft. 3 men died because NASA chose speed over safety. Their deaths forced the agency to confront the reality that space exploration demands perfection, not just ambition. The Apollo program was delayed by 21 months while NASA fixed the problems that should never have existed in the first place. Challenger. 7 lives lost on live television. January 28, 1986. Kennedy Space Center, Florida. The temperature overnight had dropped to 18 degrees Fahrenheit. The coldest launch conditions NASA had ever attempted. Ice covered the launch pad. Icicles hung from the service structure. Engineers warned that the cold could cause a catastrophic failure. NASA launched anyway. Space Shuttle Challenger lifted off at 11:38 a.m. Eastern Time. Aboard were 7 crew members: Commander Dick Scobie, pilot Michael Smith, mission specialist Judith Resnick, Ellison Onizuka, and Ronald McNair, payload specialist Gregory Jarvis, and teacher in space Krista McAuliffe. Millions watched live on television. School children across America tuned in to see their teacher go to space. It was supposed to be NASA's triumph, proof that space travel had become routine enough for ordinary citizens. President Reagan was scheduled to mention the mission during his State of the Union address that evening. 73 seconds after launch, Challenger exploded at 46,000 feet, traveling at 1,977 feet per second. The shuttle broke apart in a massive fireball visible for hundreds of miles. Debris rained down into the Atlantic Ocean. The crew cabin remained intact during the breakup. The astronauts didn't die in the explosion. They died when the cabin hit the ocean at over 200 miles per hour, more than 3 minutes after the breakup. Some of the crew were likely conscious during the fall. Personal egress air packs had been activated, meaning at least some astronauts were alive and aware as they plummeted toward the water. They knew they were going to die. The cause was a failure in the right solid rocket booster. Specifically, an O-ring seal failed at a joint between 2 segments of the booster. The solid rocket boosters were manufactured in segments and assembled at the launch site. Each booster stood 149 feet tall and burned for approximately 2 minutes, providing most of the thrust needed to lift the shuttle off the pad. Rubber O-rings sealed the joints between segments. These O-rings had to remain flexible to maintain the seal under the extreme pressures and temperatures of launch. But rubber becomes brittle in cold temperatures. Engineers at Morton Thiokol, the company that built the solid rocket boosters, knew this. They had seen O-ring erosion on previous flights. They had documented the problem extensively. They had recommended against launching in temperatures below 53 degrees Fahrenheit. The night before the launch, engineers held a teleconference with NASA managers. The meeting started at 8:45 p.m. and lasted until midnight. Engineers presented data showing O-ring problems on previous cold weather launches. They showed photographs of O-ring erosion. They argued that launching at 18 degrees was far outside the tested range. They recommended delaying the launch until temperatures rose above 53 degrees. NASA managers pushed back hard. They questioned the data. They asked the engineers to prove that it was unsafe to launch, rather than requiring proof that it was safe. This reversed the normal burden of proof in engineering decisions. In aerospace engineering, you must prove something is safe before proceeding. NASA was demanding proof of danger instead. The pressure on Morton Thiokol was intense. NASA had already delayed the launch multiple times. The agency was trying to maintain an ambitious launch schedule. Delays were seen as failures. The shuttle program was supposed to prove that space travel could be routine and reliable. Under pressure, Morton Thiokol management asked for a 5-minute offline caucus. During that caucus, management overruled their own engineers. One manager told the engineers to take off your engineering hat and put on your management hat. In other words, stop thinking about safety and start thinking about the customer relationship. Morton Thiokol management returned to the teleconference and approved the launch. NASA got the answer they wanted. The launch was scheduled to proceed. At launch, the cold O-rings failed to seal properly. High-speed cameras captured puffs of black smoke coming from the right solid rocket booster at ignition. The smoke was vaporized O-ring material being blown out through the failed seal. Hot gases from the solid rocket booster leaked through the joint just 0.678 seconds after ignition. Initially, aluminum oxide from the burning solid fuel temporarily sealed the leak. But as the shuttle climbed and aerodynamic forces increased, the temporary seal failed. At 58 seconds into the flight, the leak became a flame. A blowtorch of superheated gas at 5,000 degrees Fahrenheit cut through the external fuel tank. At 64 seconds, the flame had burned through the strut connecting the solid rocket booster to the external tank. The booster began to pivot, its nose pushing into the external tank. At 72 seconds, the flame breached the external tank. Liquid hydrogen began leaking. The structural integrity of the tank failed catastrophically. At 73 seconds, the aerodynamic forces of supersonic flight tore the shuttle apart. The external tank exploded in a massive fireball. The solid rocket boosters, still burning, spiraled away from the explosion. The crew cabin separated intact and began its fatal fall toward the ocean. The investigation revealed a culture of complacency at NASA. The agency had normalized deviance, accepting higher and higher levels of risk as routine. O-ring erosion had been seen on previous flights, but since those flights succeeded, the erosion was deemed acceptable. Each successful flight with O-ring damage made the next risky decision easier to justify. Schedule pressure played a major role. NASA was trying to prove the shuttle could fly frequently and reliably. The agency had promised 24 flights per year. They were nowhere close to that goal. Every delay made the program look bad. The pressure to launch was enormous. NASA had launched 24 successful shuttle missions before Challenger. Confidence had replaced caution. The agency believed its own publicity about the shuttle being operational and routine. But the shuttle was still an experimental vehicle. Every flight was a test flight. Richard Feynman, the physicist who served on the investigation commission, demonstrated the O-ring problem during a televised hearing. He dropped a piece of O-ring material into ice water, then showed how it lost flexibility. It was a simple demonstration that proved what the engineers had been saying all along. The O-rings couldn't function in cold temperatures. 7 people died because NASA ignored its own engineers. The warnings were clear. The data was available. The decision to launch was made despite the evidence, not because of it. NASA chose schedule over safety, and 7 astronauts paid the price. Columbia. The disaster NASA saw coming. February 1st, 2003. Space Shuttle Columbia was returning from a 16-day mission. The crew of 7 had completed their work successfully. They were 16 minutes from landing at Kennedy Space Center. Families waited on the runway to welcome them home. At 8:59 a.m. Eastern Time, Columbia broke apart over Texas and Louisiana at an altitude of 200,000 feet, traveling at 12,500 miles per hour. All 7 crew members died instantly. Commander Rick Husband, pilot William McCool, mission specialist David Brown, Kalpana Chawla, and Laurel Clark, payload commander Michael Anderson, and payload specialist Ilan Ramon, Israel's first astronaut. The cause was a hole in the leading edge of the left wing. Hot plasma from re-entry entered through that hole and melted the wing's internal structure. When the wing failed, the shuttle tumbled out of control and disintegrated. The crew cabin broke apart, killing everyone instantly. But here's what makes Columbia different from Apollo 1 and Challenger. NASA knew about the damage before re-entry. They knew the shuttle was damaged. They chose to do nothing. During launch on January 16th, a piece of foam insulation broke off from the external fuel tank. The foam was roughly the size of a small cooler, weighing 1.67 pounds. It struck the leading edge of Columbia's left wing 81.7 seconds after launch. The impact occurred at a relative velocity of 545 miles per hour. Engineers saw the foam strike on video footage the day after launch. They immediately recognized it as a potential problem. Foam strikes had happened on previous missions, but this one looked worse. The impact point was on the reinforced carbon-carbon panels that protect the wing's leading edge during re-entry. These panels had to withstand temperatures of 3,000 degrees Fahrenheit. Any damage to them could be catastrophic. Engineers requested high-resolution images of the wing from military spy satellites or ground-based telescopes. They wanted to assess the damage. They sent multiple requests through official channels. NASA management denied every request. The reasoning was bureaucratic and tragic. Management believed that even if there was damage, nothing could be done to fix it. Columbia didn't have the supplies or equipment for a spacewalk repair. There was no rescue shuttle ready to launch. So why look for a problem if you can't fix it? This logic ignored the fundamental principle of engineering. You need to know what's wrong before you can determine if it can be fixed. This reasoning was fatally flawed. If NASA had confirmed serious damage, multiple options existed. Columbia could have extended its mission while NASA rushed to prepare Atlantis for a rescue launch. The crew could have performed a spacewalk to assess and possibly repair the damage using materials aboard the shuttle. They could have reduced power consumption and waited in orbit for up to 30 days. A rescue mission was possible, but only if NASA acknowledged the problem. But NASA management convinced themselves the foam strike wasn't serious. Foam had hit shuttles before without causing disasters. They normalized the risk, just like they had with O-ring erosion before Challenger. The same organizational failures that killed 7 people in 1986 were killing 7 more in 2003. Engineers weren't convinced. They continued to raise concerns through official channels. They were ignored or told to stop worrying. One engineer sent an email stating that he couldn't get management to listen to his concerns. Another engineer requested debris impact analysis, but was told not to bother management with the request. The culture at NASA had shifted back to the same complacency that killed the Challenger crew 17 years earlier. Management didn't want to hear bad news. They didn't want problems that might delay the mission or require difficult decisions. They wanted everything to be fine, so they convinced themselves everything was fine. On the morning of February 1st, Columbia began re-entry. At 8:50 a.m., sensors in the left wing began showing unusual readings. Temperature sensors failed one by one. Tire pressure sensors showed unexpected readings. The shuttle's flight computers tried to compensate for increasing drag on the left side. The crew had no idea anything was wrong. The sensor failures didn't trigger any alarms. Columbia was flying on autopilot, and the computers were handling the anomalies. Commander Rick Husband and pilot William McCool were preparing for landing. Everything seemed normal in the cockpit. At 8:59 a.m., Mission Control lost all data from Columbia. The last communication from the crew was Commander Husband acknowledging a transmission from Mission Control. His response was cut off mid-word. The shuttle had broken apart. Debris fell across Texas and Louisiana, a trail of wreckage 250 miles long and 40 miles wide. Over 84,000 pieces of debris were eventually recovered. Search teams found crew remains scattered across the debris field. The recovery operation took months and involved thousands of people. The investigation found that the foam impact had punched a hole approximately 6 to 10 inches in diameter in the leading edge of the left wing. During re-entry, superheated plasma at 3,000 degrees Fahrenheit entered through this hole. The plasma melted the aluminum structure inside the wing. The wing failed, and the shuttle was destroyed. The Columbia Accident Investigation Board was brutal in its assessment. NASA had failed to learn the lessons from Challenger. The same organizational problems that caused one disaster had caused another. Schedule pressure, normalization of deviance, and a culture that discouraged dissent had killed 7 more astronauts. The foam shedding problem was well documented. It had happened on nearly every shuttle flight. NASA had classified it as a maintenance issue rather than a safety concern. Engineers who raised alarms about foam strikes were dismissed as overly cautious. The agency had convinced itself that foam strikes were an acceptable risk. The investigation revealed that NASA had multiple opportunities to save the crew. If they had requested satellite imagery immediately after launch, they would have seen the damage within days. If they had taken the engineers' concerns seriously, they could have developed a rescue plan. If they had prioritized crew safety over schedule and bureaucracy, 7 people would have come home. Boeing engineers conducted tests after the accident, firing foam at wing panels at the same velocity as the Columbia strike. The foam punched clean through the reinforced carbon-carbon panels. The damage was catastrophic. NASA's assumption that foam couldn't cause serious damage was completely wrong. The most damning finding was that NASA management had actively prevented engineers from getting the information they needed. The requests for imagery were denied, not because the imagery wasn't available, but because management didn't want to deal with what they might find. They chose ignorance over knowledge, and that choice killed 7 people. 17 astronauts died in 3 disasters that NASA could have prevented. Apollo 1 burned because safety took a back seat to schedule. Challenger exploded because managers ignored engineers. Columbia disintegrated because NASA refused to look at damage they knew existed. These weren't accidents. These were choices.